Hello friends, welcome to new video. Today topic is atomic bombs, which is also known as nuclear bombs, are incredibly powerful weapons that harness the energy of nuclear reactions. Understanding the intricate components that make up these weapons is essential for comprehending their immense destructive capabilities. In this video, we will explore the inner workings of an atomic bomb, shedding light on the various components that contribute to its devastating power. At the core of an atomic bomb lies a fissile material, which is essential for sustaining a self-sustaining chain reaction. The two primary isotopes used in atomic bombs are uranium-235 and plutonium-239. Uranium-235 is obtained through an enrichment process, as less than 1% of natural uranium consists of this isotope. Plutonium-239, on the other hand, is produced by irradiating uranium-238 in a nuclear reactor. These fissile materials release an immense amount of energy when their atomic nuclei undergo nuclear fission. The trigger mechanism of an atomic bomb is responsible for initiating the chain reaction. Two primary types of triggers are commonly used: implosion-type and gun-type mechanisms. In an implosion-type trigger, conventional explosives are strategically placed around a subcritical mass of fissile material, such as plutonium-239. When detonated simultaneously, these explosives create a shockwave that compresses the fissile material into a supercritical state, initiating a chain reaction. The gun-type trigger utilizes two subcritical masses of fissile material, typically uranium-235. When fired together, one mass is propelled into the other, creating a supercritical mass and initiating the chain reaction. To initiate the chain reaction in an atomic bomb, a suitable initiating source is required. Neutrons are commonly used as they can cause fission in fissile materials. The initiating source can be generated through various means, including a small amount of a radioactive isotope or an external neutron source. Explosives play a crucial role in an atomic bomb by creating the necessary conditions for the chain reaction to occur. These explosives are precisely engineered and timed to create a shockwave or impulsive force, which compresses the fissile material in implosion-type triggers or propels the masses in gun-type triggers. Conventional explosives, such as TNT, are commonly used in atomic bombs. Neutron reflectors surround the fissile material in an atomic bomb. Their primary function is to contain the chain reaction and enhance the bomb's efficiency. Materials like beryllium oxide or heavy water, deuterium oxide, are commonly used as neutron reflectors. They reflect the neutrons back into the fissile material, increasing the probability of further fission reactions and maximizing the energy output. The detonator ensures the precise timing of the explosion. It initiates the explosion of the conventional explosives, leading to the compression or propulsion of the fissile material. Detonators can be designed using various technologies, including electrical or electronic triggering systems, and their accuracy and reliability are crucial to ensure the desired chain reaction and energy release. Atomic bombs incorporate sophisticated safety and arming mechanisms to prevent accidental detonation and ensure controlled use. These mechanisms involve physical locks, interlocks, and electrical systems that require multiple conditions to be met before the bomb can be armed and detonated. An atomic bomb requires a robust containment and delivery system to effectively deploy its destructive power. The containment system consists of a sturdy casing that contains and directs the explosion's force. The delivery system varies depending on the deployment method, such as aircraft, missiles, or other means. These systems ensure that the energy released by the bomb is directed towards the intended target. The inner components of an atomic bomb work together in a precise and intricate manner to unleash an unprecedented amount of destructive energy. Understanding these components allows us to grasp the immense power of nuclear weapons and reinforces the importance of promoting peace, disarmament, and non-proliferation efforts worldwide. Thanks for watching. Also subscribe the channel.